Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with our main topic, that is differentiation. We are going to learn the second techniques of finding derivatives of some special functions, and that second technique is called the quotient rule. So let's begin. So after completing the very lesson today, my dear student, we'll be able to find the derivative of a function involving fractions using this quotient rule. This is what I hope you'll be able to do after completing the very lesson today. So as usual in our favorite segment of the lesson, Marcus funded today, I'll introduce you to a special sequence of numbers that we call the local sequence. I will explain what is local sequence after completing this my lesson today. So don't go away. To begin the lesson, let us first see some special functions that we may not apply the normal rule, that is the general rule. We have to employ another technique. So let's see these functions. Suppose you have this function y equals to, this is an algebraic fraction where you have 2 plus 3x squared as the numerator over 5 as the denominator. Similarly, if you have another function y equals to 3 over cos 3x, 3 is the numerator while cos 3x is the denominator. So the general rule there may not just be suitable, may not be adequate to find the derivative of this type of functions. So in that case, you have to employ another techniques, another method of finding derivative, and it is this method that we are going to learn in this very lesson that we call the quotient rule. So these types of functions, we now apply this quotient rule to find its derivative. So this type of special functions, we have to use another techniques, like I have said, this quotient rule. So let us learn the rule. The rule says if you have the function y equals to f of x divided by g of x, you can see this f of x, the numerator, is a function of x, and the g of x, the denominator, is another function of x, and the entire of this fraction is now what you have as your y. So this type of functions, what do you now do? You now let one of the functions there to be your u and the other one to be your v. But in this case, there is a restriction. The function at the denominator level will always be your v, while the function you have at the numerator level will always be your u. If you have that, then you can now rewrite this very function y as y equals to u over v. So you have this function. This is just the same as the original function. Instead, f of x over g of x, you now have y equals to u over v, where u, you can see that it is nothing but f of x, and v is nothing but g of x. So if that is the case, the rule, that is the quotient rule, says if you are to find the derivative of these kinds of functions, what you now simply do, you make use of this rule, that is this very formula. It says dy by dx is equals to v multiplied by du dx minus u multiplied by dv dx all over v square. This is the rule. Let me repeat. Dy by dx is nothing but v multiplied by du dx minus u multiplied by dv dx all over v square. In this case, you have to be careful. What you have at the denominator level is going to be v square all the time, not u square. It's going to be v square. And what you have here as denominator first is v first times the du dx, then minus u times the dv dx, because this is subtraction, not addition. And remember, subtraction is not commutative. If it were addition here, then there is no problem having any of the two to be first. So we are going to make use of this very formula and find the derivative of some functions. So let me just move. Example number 1, it says find the dy by dx if you have the function y equals to x raised to the power of 2 over cos 3x. Solution to this very problem. What you do first is to copy down your original function given, that is y equals to x squared over cos 3x. looking at this function, you can see that it is a function of x at the numerator level and another function of x at the denominator level. That makes you think that it is quotient rule that you are going to apply. So my rule, quotient rule, says dy by dx is equals to v times du dx minus u times dv dx all over v square. So what remains is to make your numerator u and the denominator v. Let me do that. So my u is now going to be x square. Look at it. And my v is now going to be cos the 3x. So what remains is to find the du dx, that is derivative of the function u, and the dv dx, that is derivative of the function v, because I need them all here in this formula. So let me move. So du dx is nothing but derivative of x square is nothing but 2x. And the dv dx, that is derivative of this cos 3x, is nothing but minus 3 sine 3x. So I'll now move to down this very formula and substitute my v. You can see this is the function cos 3x. Then du dx is this 2x. So let me do that. So v times du dx, I'm going to have cos 3x times 2x. 3x is now cos 3x is now your function v, and 2x is now this du dx. Look at it here. Then minus the function u, which is x square, times dv dx, which is now minus 3 sine 3x. So let me write it there. I'm going to have x squared times open bracket minus 3 sine 3x all over my v square, and v square, remember, is this cos 3x. So I'm going to have cos 3x raised to the power of 2. I continue. So what remains is to perform these multiplications. So cos 3x times 2x, that gives you 2x cos 3x. Then x squared times this very bracket. Inside the bracket, remember, here is minus x squared times this. It will going to change it to plus. So you're going to have 3x squared positive sine 3x. Look at it, 3x squared sine 3x, then all over. This is cos 3x. You just copied it. Raised to the power of 2, that is cos square 3x. Cos 3x outside the bracket raised to the power of 2 means cos 3x times another cos 3x. That's what gives you cos square 3x. And this will now be the derivative of this very function. So let's just take one more example. Example number 2, it says find the dy by dx if you have the function y equals to x raised to 3 plus x all over x raised to power 4 minus 2. Solution to this very problem. What we now do, we copy the given function y equals to x raised to 3 plus x over x raised to 4 minus 2. So what remains is to write down your formula for quotient rule, where it says dy by dx is equals to v multiplied by du by dx, that is v multiplied by du dx minus u times dv dx all over v square. So what remains is to let your numerator to be your u and the denominator to be your v. There I continue. I have u to be equals to x raised to 3 plus x, and my v always is the denominator. That will now be x raised to 4 minus 2. So what remains is to find the derivative of u and derivative of v. Du dx is now going to be derivative of this function. There gives me 3x squared plus 1 as the derivative of the function u with respect to x. And I'll now move ahead and find derivative of v, that is this dv dx, with respect to x. That is going to be 4x raised to 3. So dv dx is now nothing but 4x raised to 3. Derivative of this to 2 is 0. So I'll now substitute inside my formula, inside my quotient rule. I have x raised to 4 minus 2 that is my function v. Then times du dx, which is 3x squared plus 1. Look at it here. Then my minus sign in the formula. Then the function u times the dv dx. This is the function u, and this is your dv dx. So you now have x raised to 3 plus x times 4x raised to 3. This bracket is your function u. Look at it here. X raised to 3 plus x, and 4x raised to 3 is dv dx. Look at it here. Then all over v square, and this is your function v, x raised to 4 minus 2. So you're going to have x raised to 4 outside the bracket raised to the power of 2. This power 2 is for this v square. So I'll continue. So I'll now simplify by expanding this bracket there. I'm going to have my x raised to 4 times 3x squared and this. So expanding those two brackets, if done correctly, you now have 3x raised to the power of 6. This is x raised to 4 times x times 3x squared. That gives you 3x raised to the power of 6. Then x raised to 4 times this positive 1 gives you positive x raised to 4. Then minus 2 times 3x squared gives you minus 6x squared, and minus 2 times positive 1 gives you minus 2. There also I'm going to multiply this bracket by 4x raised to 3. There I'm going to have, if done correctly, you now have 4x raised to 6 minus 4x raised to 4 all over. Also copy that very bracket, x raised to 4 minus 2 outside the bracket raised to the power of 2. So there you now check if there are terms that are alike, which you can add them up together. You do so. You can see term with the power 6. This is another term with the power 6, so they are alike. Similarly, I have a term with the power 4. I have another term with the power 4. They are alike also. So let me collect those two terms. So those terms are like 3x raised to 6 minus 4x raised to 6. That gives you minus x raised to 6. And x raised to 4 minus 4x raised to 4. That gives you minus 3x raised to 4. There you now have this result, minus x raised to 6 minus 3x raised to 4. Then copy down this minus 6x squared and copy down this very minus 2. And this is where you can stop here. This is the very derivative of this function y. So with this, I have come to the end of this lesson, my dear student. I hope with a few examples given, you also be able to use the quotient rule to find the derivative of functions that involve algebraic functions. Thank you for your attention, and let me just move to the last segment, as is fun, and give you what we call the Lucas sequence. So Lucas sequence is another special sequence of numbers. And this is just a sample of it. It started with 2, 1, 2, 1, 2, 1. This is the very first few terms, the very first two terms. Then other terms, you obtain other terms by adding the last two terms. So if you add 1 and 2, it will give you the next term. If you add the 1 and 3, it will give you the next term, which is 4. If you add the 3 and 4, it will give you the next term, which is 7. The addition of 4 and 7 gives you the next term, 11. So this is what we call a Lucas sequence. If you ask to continue writing more terms, I believe next term will be addition of 29 and 47. It will give you the next, and so on. This is a Lucas sequence. This sequence has a lot of interesting properties, which we shall see in our subsequent lesson. So Lucas has a lot of interesting properties, just like other sequence of numbers that we have seen before. So thank you for your attention. We see more of this in our next lesson.